Hello everyone, my name is Abhishek and welcome back to my channel. In today's video, you will learn how to create, train, evaluate, build and deploy a machine learning model. So this is going to be a beginner friendly MLOps project and you will learn this entire project using a real-time machine learning model, that is diabetes prediction model. So I have written this model. So in this video, I will also walk you through the code. I will explain you how does this model work, and then I'll explain you how to train, evaluate, build and deploy this model. But before that, a lot of you might be new to MLOps and some of you might be worried as well that MLOps is difficult. Let me tell you, if you come from DevOps background, I'm sure a lot of our subscribers come from DevOps background. So learning MLOps is just a piece of cake. Why? Because MLOps is considered as DevOps for machine learning. Why? To understand this, let's go a step back and understand what exactly is DevOps. So DevOps is a culture that unifies development and operations. In other words, you can say DevOps is a culture that bridges the gap between development and operations. If you look at software development lifecycle, for a company to ship a feature, multiple stages are involved. So initially, requirements have to be gathered. Once the requirements are gathered, then the developer works on design and developing the feature. Once the design and development of the feature is done, application is built with the feature. Then the application is tested. Then the application is deployed. And finally, application is monitored for a good amount of time. And this is not a one-time process because initially developer might succeed in the first attempt in developing the feature, or maybe a QA engineer says, hey, the feature is not working fine. So developer goes back, again updates the feature, might again, and do it n number of times. So typically, even for a single feature, all of these activities have to be repeated n number of times. So this is where for companies to ship a feature before DevOps, it used to take 2 to 3 months. Now, DevOps came into picture to reduce the gap between development and operations and to reduce this entire time. So now a DevOps engineer tells the developer, hey developer, just focus on development. Rest, I will focus on automating the things for you. So once you feel that your feature is ready, you can run the pipeline that I've created, and that pipeline will build your application. It will test your application. It will deploy, and it will also monitor the application for the results. So this way, even if the developer has to go through multiple iterations, it will not take 2 to 3 months, but it might take some 20 to 30 days. So DevOps will significantly reduce the gap between development and operations, increasing the efficiency of the software development lifecycle. Now, just like software development lifecycle, there is also something called as model development lifecycle. Because end of the day, whether it is software development or model development, developers have to go through number of iterations. Imagine there is a engineer who is working on developing a model, let's say climate prediction model, right? Or a weather prediction model. Let's just say WM. Now, to develop this model, the engineer has to go through multiple stages. Initially, data has to be provided because for weather prediction model to predict weather in the future, initially huge amount of data has to be provided to it, maybe 100 years of data or at least 50 years of data of temperature of a particular region. By looking at this data and by training on this data through some machine learning algorithm, what does the model do? Model predicts what can be the temperature of a particular place on 1st of July in 2025. So data is important, algorithm is important, developing the model is also important. So to do all of these things, multiple stages are involved. Initially, data has to be ingested, then the data has to be prepared. Because this data is collected from various sources, the data might be not properly organized. So the data has to be prepared so that the data or model can be trained on the data. And once the model is trained on the data, who knows? This weather prediction model might return accurate results or might not return the accurate results. Let's say 100 years of data is provided, but still the model developer has used a weak algorithm, right? So in that cases, you need to evaluate the model and maybe model might fail at the evaluation. Or if developer has used a very good machine learning algorithm, something like random forest, the performance of the model will be good. So model training, model evaluation, then the model also has to be deployed, right? Before the model has to be built. And finally, model has to be monitored. Usually in case of most of the models, model has to be retrained as well. Because when it comes to models, performance usually goes down as new data keeps adding. So model also has to be retrained. Now, what I'm trying to tell you here, just like software development lifecycle, the stages within the model development lifecycle will also be repeated multiple times. Because in terms of model development as well, the developer might not be successful at the very first attempt, or the engineer might not develop model accurately at the very first attempt. So there will be number of iterations. As there are number of iterations, model training has to be repeated, model has to be built multiple times, model has to be evaluated multiple times, it has to be deployed multiple times, and this activity is taken care by MLOps in Snare. So that is why MLOps is inspired by DevOps or inspired from DevOps. Before MLOps, it used to be very difficult because they say that 80 to 90% of machine learning models actually never reach to production because it used to take a lot of time. So most of the people, they used to develop the models locally and they used to ignore all of these stages. In the recent times, MLOps has become very significant for the same reason. Now, a lot of companies are working on developing their models, and for the development of their models and releasing the models, they are using MLOps. So MLOps is inspired by DevOps. Because if you are a DevOps engineer, you already know and you have expertise in platforms like GitHub Actions, Docker, Kubernetes, Terraform for creating infrastructure. Most of these platforms are also used in MLOps. That's why it's actually a piece of cake to learn. Only challenge that you'll find is understanding model development lifecycle. So in this video, I will first explain you how models are created. Because I have created this model and I am the author of this model, I can quickly walk you through the source code and I'll explain you. Then I will show you how data is collected. Then I'll show you how model is evaluated. Once you understand these things, only then I'll proceed with explaining you how to build the model, how to deploy the model onto Kubernetes. So you will be learning all of these in next 15 minutes. Perfect. So let's get started with understanding how data is collected and how the models are created. So in our example, we are using database prediction model. But Abhishek, what exactly is this data prediction model doing? As the name suggests, if you provide it with bunch of parameters, it will tell if a person is diabetic or non-diabetic and the parameters that it expects. So it will expect these parameters in the JSON format: pregnancies, glucose, blood pressure, BMI, and age. So this should work for both men and women, or male and female. So that's why pregnancy is also important parameter. If you want to know if a man is diabetic, maybe you can just mark the pregnancies as 0. Then you provide glucose levels, blood pressure, BMI, age. Of course, it is trained on huge number of other parameters as well, but these are the important parameters. If you just provide these 5 parameters of a patient, it will say if the particular person is diabetic or non-diabetic. But Abhishek, how is this developed? And first of all, where did you get the data from? Like in the theory part, you explained for a model to function, it needs huge amount of data. So where did you get the data of huge number of patients? At least you must have gathered some thousands of patients. Only you can say that this model is returning accurate results, right? Only then you can consider this model as even something in the working state. So you don't have to worry about that. There are a lot of sources on internet, and one of such source is Plotly. So if you're working on a proof of concept, let's say something like weather prediction or something that I've done, diabetes prediction. So you can use data sets that are available on internet. Fortunately, most of them are freely available. Plotly also provides huge data sets as free resources. For example, you're working on world GDP, or maybe you're working on US airport traffic. In my case, I'm working on diabetes. So I've used the CSV file that is provided by these datasets. So this is the CSV file that I've used. Now, if you look at this way, you might feel what exactly it is. Let me simplify. So these are the headings, or this is the header where first column is number of pregnancies. Second column is the glucose levels of the person. Then blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age, and finally the outcome. So basically, what we are telling the model, right? We are asking the model to use an algorithm. So basically, I have used random forest as an algorithm. I'll also show you the source code in next 1 minute. But for now, just understand, to train the model, I have used random forest as algorithm. And I'm telling the model, these are the parameters and this is the outcome. That means if number of pregnancies is 6, if glucose level is 148, blood pressure is 72, skin thickness is 35, insulin is 0, BMI is 33.6, and diabetes pedigree function is 0.62, and age is 50, then the person is diabetic. Similarly, I said here is information about other person, where number of pregnancies is 1, glucose levels is 85, blood pressure is 66, 29, 0, 26.6, and this person is non-diabetic. So this way, I have provided 1,000 plus data sets to the model, and I have asked the model to use random forest algorithm, which works perfectly fine in these kind of data sets. So after training on these data sets, now my model can say, if you provide the following things as input, right? If you provide these things, pregnancies, glucose, blood pressure, BMI, and age, you don't have to provide all of them. Just provide these things in the JSON format, and it will immediately tell you if a person is diabetic or non-diabetic, right? So this way, open source helps you a lot, or these free resources helps you a lot. You don't have to collect the data. Okay, perfect. Now, now that we understood how the application works, let me quickly go through the source code as well. Now, this is up to you. If you're not interested in the source code, you can completely ignore it. But for people who are curious how this works, so I've written this train.py, and within the train.py, I'm first getting the information from the CSV, right? This is data ingestion. If I explain you through this chart again, so first we have ingested the data, right? So we got the data. Then I'm serializing the data, or you can consider I'm preparing the data using pandas. So I'm reading the data from the CSV file and I'm preparing it. Okay, this is also done. Now we have to train the data, train the model. And for training the model, we need an algorithm. Either you can develop your own algorithm, or fortunately, there are so many good algorithms that are available on the internet, right? So once we have the data prepared into the x-axis and y-axis, right, we have good algorithms like random forest. So I'm using this random forest algorithm, which is publicly available, and training my model. And finally, because users cannot directly interact with the model, like imagine if I just provide this model, you cannot directly interact with it. So if you want a user to interact with the model, usually models are placed in software applications. So in Python, you can use Flask or you can use FastAPI, which is very widely used these days. So I'm writing a software application in FastAPI. I will come to it, but for now, and I'm placing the model within this software application. So user can interact with the model not directly, but through this application, because FastAPI will expose something called a REST API like predict. So user will interact with this software application on the predict API. From there, interaction takes place to the model, and model again returns the information to the application, and application returns the information to the user. So usually models are not directly interacting with the users. Models are mostly put in the software applications and shipped as software applications. Okay. But Abhishek, how did you do it? Very simple. So we will uh, save the model in the PKL file format. So I'm using joblib, which is basically a module or a package. Using that, I'm saving the model in the .pkl format, diabetes model.pkl, and this pkl file. If you see, I've written something called main.py, which is this fast API, which is written using fast API. And here I'm using this file, diabetes model.pkl. And in the fast API, I'm creating using fast API, I'm creating slash predict endpoint. So user will interact with the slash predict endpoint. So what we will do as a next step, because we are done with, so let me quickly show you, my bad. Okay. So because we are done with data ingestion, data preparation, model training as well. So all that we need to do is execute the previous file, that is train.py. Once you execute this train.py file, so it will create the PKL file, and then we will evaluate the model using fast API. So let us check the training and evaluation stages. Okay, I just explained it theory part. Now I'll show you how to train the model in real time and how to evaluate the model. Then we will look at building and deploying. For that, I will pull my terminal. Okay. And within this terminal, let me create a folder, mkdir, let's say demo MLOps. Okay. I will switch the directory to demo MLOps. Great. Now I need the GitHub repository URL. This is a public repository, and all the steps that I'm going to implement are already put in this README file, right? Every step, in case you are stuck in the video, don't worry. Just go to the README file, look at the commands that I'm executing. You will find everything. Anyways, I'll also explain them. Okay, so copy the URL, go back to the terminal, git clone followed by URL. Okay, great. Now let's switch the directory to first MLOps project. Cool. Okay, so we have the source code here. Everything is fine. Whenever you are working with Python project, make sure you create a virtual environment. Why virtual environment is important? Because on this particular machine that you see, I'm running multiple Python projects. And with Python, a common challenge is that you will find dependency conflicts. One project might be using a specific Python dependency, and other project might be using a specific dependency version. So always it is good to create virtual environment so that at the namespace level or at the packages level, isolation is created. Very simple. Python 3 hyphen m v env. Right? If I'm already in a virtual environment, let me first deactivate it. Okay. Now Python 3 hyphen m v env. Let's call this as .mlops. I'm using dot because I want to keep this virtual environment in a hidden format, so that whenever you do ls, you will not find the virtual environment. You'll just find the source code. And this way I can also add it to git ignore and not push to the git repository. Okay, now let's source the virtual environment. Source.mlops bin activate. Okay, great. Now first, let's see how to train the model. Python 3 train.py. That's all. So to train the model, you don't have to do anything additional. Just run Python 3 train.py and it will create the .pkl file where it is saving the model in the pkl format. Abhishek, it says no module name pandas. Don't worry. We have the requirements.txt file. Just run pip3 install -r requirements.txt. Obviously, if you want to run the model or even if you want to build the model, you need to have the dependencies. That's where it failed. It's totally fine. Now the dependencies are installed and installed in the virtual environment. I will run Python 3 train.py. This will take less than a minute, but it will take some time depending on your spec, on your machine spec as well. It might take more time. But once this execution is done, in this folder, you will find the diabetes model.pkl file. And as I told you, we will use that in the FastAPI. Okay, let's wait for few more seconds. And it says model is saved as diabetes model.pkl file. Now, what I was trying to say, user cannot interact with this, right? For user to interact with this model, you need an API, you need an endpoint. So that's why you will place this in a software application. Now we already have this file called main.py. How do you execute it? Because we wrote it in FastAPI, you will use uvcon. So uvcon main colon app followed by -- reload. So this will start a development server for us. And this development server will host the application on this particular URL. So I'll just copy it, go back, and in the browser, I will open this endpoint. What does it say? Diabetes prediction API is live. As I explained in the theory part, and even if you look at the source code, right, main.py, what endpoint is exposed? The endpoint that is exposed is /predict. So I can just go to my postman, or I can just use curl command and pass /predict with the JSON information. However, the best part about FastAPI, it comes with a REST API client. So all that you need to do is go for the endpoint /docs. So here you can directly access get endpoint and you can directly access predict endpoint as well. So you don't need any postman or you don't need curl or any other REST API client. Try it out, click on it, change the parameters. Like you can provide number of pregnancies, glucose, blood pressure, BMI, age, and the model will tell you if the person is diabetic or not. For safe side, I have provided information on the GitHub repository as well, or you can directly edit the field here. But this is something that I have verified. If pregnancies is 2, glucose is 130, blood pressure is 70, BMI is 28.5 and age is 45. This patient should be diabetic. Let's see if our model returns accurate information or not. So we are performing model evaluation now. If you scroll down, it says yes, the patient is diabetic. So we have confirmed the model training stage and we have completed model evaluation stage as well. Till now, model is running locally on our machine. We haven't built the model. We haven't deployed the model to the Kubernetes cluster, right? So I hope till this point it is clear. How did we uh, run the training of the model and how did we run the evaluation of the model? Only point which might be confusing to you. Why did we use FastAPI? Right? Abhishek, you have written the model code to train the model. You have written train.py. But why did you use FastAPI? I am confused there. Very simple. I'm repeating again because there might be beginners. Mostly, right? Models cannot perform direct interaction with the users. Models are shipped through software applications. So they are bundled in a software application, and software application is the one that exposes the endpoint to the user. You don't have to use FastAPI only. You can use Flask, you can use Django. But the good part about FastAPI, even when there are concurrent users, it can handle effectively. It comes with great, uh, concurrency as well. So that's why FastAPI is used. It's very fast. Okay. Now let's head back and see how to build the model and how to deploy the model. Okay. For that, what we will do, the steps are in the GitHub repository as well. But if you go to the code that you have cloned, right? Let me stop it here, right? Here, you need to write a Docker file. So Abhishek, even for the models, we will be using the Docker file. Yeah. So even for the models, you can use the Docker file and you can completely use these models by building them as Docker images. So that's why I was telling you, if you know DevOps, it's actually a piece of cake for you because most of the tools that we use as DevOps engineers, the similar tools are used in MLOps as well. So let's create a Docker container now. For that, we will use the Python base image from, okay, from Python 3.10. Of course, you can use the latest version as well. From Python 3.10, let's select the work directory as /app. It's up to you. You can go for different working directory as well. And I will copy the files. Typically, our source code files are here. So I will copy them from dot to /app, right? Which is a working directory. Now, what did we do? As first step, while we were training the model locally and while we were running it locally, we executed pip. So we will do the same thing. Pip install -r requirements.txt. Great. Now in the CMD or entry point, you just have to place the command that we use for evaluation. So this was the command that we have used. So I will pass the same thing. UVCon main app. It's better to use host 0.0.0.0 because this will map with all the networking interfaces on the Linux host. So 0.0.0.0 port 8000, right? So I will save this Docker file and you need to have Docker running. Just quickly verify Docker PS. Okay, I have the Docker image running. So I will run the command docker build -t. So let me call this as database -model. You can provide Docker image name tag as per your comfort. Diabetes model demo. Okay. So now a image is being created. Once the image is created, you can just push this image to your Docker Hub, or you can push this image to your image registry, and you can share it with anyone. So this is how you build the models. Very similar to software applications, right? It is very similar because end of the day, you are actually building a software application and you are placing the model within this particular software application. Okay. But Abhishek, where did we copy the .pkl file? If you remember, because we executed these commands locally, the .pkl file is also copied, right? So .pkl file is also in the dot location, cat docker file along with source code, right? Along with the source code, we are also copying the .pkl file using this dot. Okay, we can quickly verify, right? So I will run the docker run command to quickly show you. Diabetes model demo. So I think this was the name of the tag that we provided. Cool. So it is running, but this time on a different URL. Let's access it. So I can access it and I can see diabetes prediction API is live. And again, if I go to the docs endpoint, it will work absolutely fine. So this way we have built the model. And in fact, we have also deployed it locally on our machine. But mostly, many of you might want to see how to deploy this on a Kubernetes cluster, because at the end of the day, usually models are deployed on Kubernetes cluster. So I'll also quickly show you how to put this on a Kubernetes cluster. Again, I'm repeating, if you are not sure about any command that I'm executing, you will find that in the GitHub repository. Please don't worry about it. Focus on the commands that I'm executing and the steps that I'm following. You don't have to copy anything. Okay, cool. Now, what is the next thing? To place it in a Kubernetes cluster, we need the Kubernetes manifest, right? So I'm going to provide you the Kubernetes manifest. Vim deploy.yaml or YML. We just need to, so I'm using this particular deployment file. Nothing is different. If you know Kubernetes deployment, everything is actually common. Only thing I'm using 2 replicas for high availability. And I will be using image that I will push to my container registry. So I have to tag the image. I will tag the image as something like this, Abhishek F5. Okay, Abhishek F5 slash, I will call this as diabetes hyphen model hyphen demo colon v1, right? And then I'm using the service type as load balancer, because if you're running this on Kubernetes cluster, maybe EKS or AKS, you can also expose it. You can share it with your friends. You can share it with your colleagues. In my case, I will just run it on a kind cluster. So for now, the first job, let me save it. I cannot directly run this. First, I need a Kubernetes cluster. So on my local machine, I will say kind. So I'm using kind. If you want, you can use Minikube as well. Kind create cluster hyphen hyphen name is equals to demo MLOps. At some places, you might feel that I'm going fast with respect to Docker or Kubernetes commands. The reason is that many of you are already good with Docker and Kubernetes because you come from a DevOps background. So that's why I'm not stressing on the commands that I'm using. For example, I did not talk about kind here because I believe most of you are aware of a kind Kubernetes cluster. If you're not aware, just search for Abhishek.Veeramalla kind or Abhishek.Veeramalla Docker. You have complete courses for free on this YouTube channel. Okay, so let's see. kubectl config current context. My bad. So kubectl, or I can just do kubectl get nodes to see if I'm connected to the cluster. Yeah. So demo MLOps control plane. Great. It's a single node cluster. Now, if I do kubectl apply -f deploy.yaml, the pods will obviously fail because I haven't pushed the Docker image. So this is the Docker image. Abhishek.Fi diabetes API. Sorry, diabetes model demo. So I need to take this image. First of all, I need to tag it, and then I need to push to Docker Hub. So for that, I will copy this image ID, right, which was created 5 minutes ago. Copied, Docker tag the image to Abhishek fi slash, what was the thing that we used in the deploy.yaml manifest? Let me check again. Deploy.yaml. Better to copy it. Great. So I will copy it, and before that, I will run Docker tag the image that we copied. Perfect. Okay. Now we should see if I run Docker images. So you would see Abhishek fi diabetes model demo colon v1. So now I will run Docker login. So Docker login. I have logged into my Docker hub using Abhishek fi as the username. Docker push followed by this particular thing. Once this is pushed, then I can run kubectl apply -f. My pods and service will be created. Okay, perfect. So we have this pushed. Now I will run kubectl apply -f deploy.yaml. Okay, so it says deployment is created, service is created, but let's check the status of the pods. Yeah, so they are still in the creating stage. Deployment is created, but the pods are still in the creating stage. Once the pods move to the running state, only then we can verify. Right? So let's wait for the pods to be in the running state. Okay, so the pods are in the running state. Because I'm using a kind Kubernetes cluster, although the service is exposed in the load balancer service type, I cannot directly access it. So what I will do, I will use port forwarding, kubectl port -forward svc slash the name of the service, diabetes API service, followed by the port on which I want to expose the application. Let's say 1111 colon the port of the service colon 80, and I I will also mention hyphen address is equals to 0.0.0.0. Okay, so this is the port forwarding command, and now it says Abhishek, you can access the application on localhost 1111. Let's verify if the application is deployed on the Kubernetes cluster and if I can access the model. So localhost 1111 followed by demo. Sorry, followed by docs, so that I can directly access the REST API client. Okay, I can access it. I will also try to evaluate the model. So I'll say pregnancies as 1, glucose as 60, blood pressure as something like 90, BMI is 23, and age is 25. Execute, and let's see what does the model say. Diabetic as false. So this is how you can deploy the model onto the Kubernetes cluster as well. Overall, you will find everything that I've done in the README file. In case you don't find it, by the time the video is uploaded, don't worry, I will just recheck the README file and I will update with the relevant files. So this is about the video. I hope you enjoyed and I hope you understood how MLOps project is implemented. The only missing thing is implementing the continuous pipeline, because there are a lot of beginners. I didn't want to complicate it. If we just add all of these steps to a GitHub actions pipeline, that's it. You have automated end-to-end MLOps. But for now, the intention is to explain you how MLOps is implemented, what is training, what is evaluation, what is uh, building of the model, how model is deployed to a Kubernetes cluster. I wanted to show all of these things, including the data ingestion and data preparation. So we have covered data ingestion, data preparation, model training, model evaluation, model building, model deployment. Only thing, we have to place all of this in a GitHub action pipeline, and your MLOps project is implemented end to end. And don't worry, we will do that in the next lectures of the YouTube channel. So it will be on the same channel in the coming days. Thank you so much for watching today's video. See you all in the next one. Take care. Bye bye.